Okay, this little lecture is going to be on the topographic features in the Pacific Ocean. So if you have two sheets of paper, I would tape them together, or you're going to have to draw small and squeeze it into one sheet. Okay, we're going to start. I'm going to start actually over in Japan. And we're going to go this way towards the United States. So first, we're going to start out with a volcanic island arc. That's going to drop off into a shelf. So Japan is actually a volcanic island arc. So I'm going to draw my water, just so we know that that part's above the ocean. This would be considered I'm going to call that a continental shelf. And that's going to lead into a continental slope. And down here we have a trench. I'm going to pause here. I'm going to identify my plate boundary. So Japan is actually part of an oceanic plate. And this is what we call a active margin. It's considered active because we have plates moving towards each other. So since those plates are moving towards each other, this plate is sinking down, creating a subduction zone. And when this plate sinks down, we get a trench. So this whole valley kind of a thing is a trench. This is going to be a lot deeper than a mid-ocean ridge. It's called an active margin, again, because those plates are coming together. My trench is going to come up and hit a abyssal plain. And sometimes within my abyssal plain, I may get what's called a seamount, which is an extinct volcano with a rounded top, or I may also get a Guyot. A Guyot's an extinct volcano with a flat top. So the difference between these two is the seamount never makes it to the surface of the ocean. A Guyot, for example, is a volcano that eventually, or I should say at one point, was above the ocean, the surface of the ocean. And since it's above the surface of the ocean, I'm going to extend this up. This is what it may have looked like. The waves have a lot of energy, and the waves will constantly erode the top of the mountain off a lot faster than any other part, so we end up getting a flat top. So Guyot's an extinct volcano that at one point was above the surface of the water and then got eroded away. Now these, like a mid-ocean ridge typically is symmetrical. These might be somewhat random. They might, I know like Hawaii has a lot of these because there's a hot spot there, but that's not at a plate boundary. Okay, moving on. Again, these are in the middle of an abyssal plain. You may get, some of these might come in groups, like the Hawaii Islands have like a long chain, but they may not be too. And I'm gonna go towards California. And then that's gonna come up into land. So this would be my continental rise. Continental slope. And my continental shelf. I'm going to draw my line to represent the difference in crust. So this is my continental crust. This is an oceanic plate. I could have said plate over here. This is going to be a passive margin. Because there's nothing moving. Those plates are not moving in relation to each other. So let's compare, do a quick comparison of active versus passive margin. So I'm just going to fold my paper so we can see it. So active margins, you get a really short continental shelf, a really steep slope, and usually not a continental rise. If it's coming off of the land, not necessarily an oceanic plate, you might get a little bit of a rise here, but not much. And that usually ends up in a trench. In a passive margin, you get more of a rise, your slope is not nearly as steep, and your shelf is a lot broader. So active margin versus passive margin. Active margins come together, and that kind of squishes. There's not a lot of time to build up sediment, and you got a plate sinking here, so the features kind of get scrunched. There, the passive margin is much more spread out. And I guess I should label this side. This side's going to be the United States. I kind of said California because northern, like Washington, we don't really have much of a passive margin anymore. And that's why we have the volcanic mountain range, like Mount St. Helens over there. Okay, so that's the Pacific Ocean. I'll zoom out here so you can see.